Thank you, Antonella, for your very kind introduction. And I also very much appreciate the invitation to present a keynote lecture here at this conference. Let me start with an anecdote. A professor dies and arrives at the pearly gate. St. Peter says, "We will let you in, but you must first give a lecture." The professor happily agrees. "Oh yes, of course, with pleasure. I am expert on control theory. I know everything about linear systems." "Okay," St. Peter says, "but remember, Rudy Coleman will be in the audience." So, my lecture is on linear systems. So, the parameterization, named the Youla-Kučera Parameterization, refers to parameterizing all feedback controllers that can stabilize a given plant. The outline is shown here. I will talk about motivations, basic theory, historical notes, a lot of examples, and also some industrial applications. Here is a typical control problem. Given a plant, S, determine feedback controller, R, so that the closed-loop system is stable and meets additional performance specifications. Here is the generic feedback system with inputs R and D and outputs U and Y. And it's quite logical to stabilize the system first because it's the basic specification, stability, and then addressing the additional specifications one at a time. But to do this, however, all solutions must be determined before proceeding to the next step, because otherwise, if one controller is missing, it might be the optimal one. So this is the motivation and the reason why we need to have all stabilizing controllers. We consider systems that are linear, time invariant, described by differential equations in state space form, where U is the input, X is the state, Y is the output, A, B, C, D are matrices of appropriate sizes, and the system gives rise to the transfer function, as shown here, which is a proper rational matrix.